Mm. Hello, everyone.
Hello.
Sorry, I'm late. My system had to make updates before it logs me in. Sorry about that. And
That's a classic.
tonight we are going to be dealing with topic 7. In topic 7, we have 3 assignments. This is the first assignment. In this assignment, we are going to be dealing with the serial port and USB. Our processor 80 mega, this is a family. It has an integrated universal asynchronous synchronous receive and transmitter. This is abbreviated as USART. This is already built in. That is how I may program it. But in other cases, in old versions, they used to have a serial port. This serial port, it looks like this one, and it takes the data through 2 pins, and as we're going to see, those 2 pins is TX, that is for transmitting, and receiving RX. The Arduino is equipped with bootloader. Bootloader, that means I can program my computer and load it to the computer through the serial and USB ports. Here we have in our system an intermediate IC that is MU2 or 16U2 that is taking care of the conversion between the serial and the USB. The processor we have, it has the serial port built on it, so I do not have to get an external equipment. And I have this IC, as you can see it. This will make the transfer between the USB and the processor serial. In our system, we have already used the serial function. When did we use it? When we use these 3 commands, as we're going to use them in step 1. Serial begin. We state the baud rate, that is 9600, and I can send a message to the serial port. serial print or serial print line. Here we are gonna read a value, and this value, it is a potentiometer, or it can be anything, and it's gonna be connected to A0. And this value, we are gonna print it out as a percentage, and we can use what is called the map function. This is the map function. It tells the range. We have a range for our analog to digital converter. That is 0 to 1023. And what will be my output as a percentage? It's going to be ranging from 0 to 100. So I would need, as we used it several times, an analog read. Then I will print my output. And I wait 1 second, that is 1000 milliseconds, and print another one. Here we need this program. Then our second program will be, here we are gonna use special characters. Special characters, that can be a new line, that can be a tab, that can be any character that you want. Here we are gonna build this table that will be printed on the serial monitor. We're gonna get readings and print them out. Then we're gonna go to step 3. Step 3, the data we can print it in decimal, hexadecimal, octal, or binary, and we have the command for doing that, and we're gonna try it also. So in this, we have 4. For how we can send commands from the computer to Arduino. Here we're gonna send the commands from this. We're gonna use here this part for sending commands to the Arduino. And here we use send, and please make sure that you have here a new line. So each time you send, you go to the next one. Here we're gonna send, for example, number 1. And if Arduino receives number 1, it means you can go and get or do something. Do like what? Get data, print. So we are receiving some data, and according to this data, after reading the data, we are deciding on what to do. Here, please make sure that when receiving data from the serial monitor, it comes as a character. So this character, we check if it's serial available, we get the character. Now we can do whatever we want according to the character received. We're gonna deal more with characters in our next assignment. For this assignment, you are gonna see that we have 4 programs to do. Are those clear enough? Should I continue?
Seems clear to me.
Explanation?
No, they seem clear.
Okay. Our next task will we have 3 programs to do. As I said in the last one, we are going to emphasize the character. This is the ASCII table. The ASCII table, each character that you can type, it is converted to an ASCII code. The ASCII code is 7-bit. So we have 2 to the power 7, that is 128 different characters. Those are listed in here. Now, if I wanna send the number 5, the number 5, when I type it, it is not a number, it is a character. Where is 5? Here is it, 53. It will be decimal 53. But as a character, as you input it, it is going to be 5. And in decimal, it will be in hexadecimal 35. So how could I get the 5 in decimal? So first of all, I need to convert it to the number that is 5. There are many ways for doing that. First of all, I have here, if serial read, I've entered number 1. I put here, I inputted a value. If this value, which is a character, that's why I am comparing it with 1 with single quotes. So the 1 here, it is not our decimal 1. No, it is a character. And this character is denoted by this single quote. So I'm comparing my serial read with this one. This is one way to detect the character, but this is for limited options. The other way is to convert it to its equivalent decimal number. We can do that by using this command. I have value. This value will be a number, a decimal number. I do that by subtracting serial read from the character 0. When I subtract that, I am removing all the ASCII before and I'm starting a new numbering. But this only would work for numbers 0 to 9. If I have double-digit number, it will not work. The third one, which is the most important one, which we used last semester, it is to use the parse. Parse int. Parse int will make the conversion and you have a decimal number directly. We used it last semester, and here we may use it again. According to a number, this we're gonna do a simple one. According to the number you are receiving, 5, 6, 7, whatever you like, you are gonna decide on turning on this light emitting diode. This will be our first task. Our second task, we are gonna send multiple digits. For example, I have here this RGB and I wanna give it different colors. So we are gonna use this. Of course, this needs more than one input to work. We are selecting the light intensity, we are selecting the color. And by the way, if you don't have this one, and you have your circuit breaker ground. We used it also before. Finally, this will be your choice to get an application of this serial in, serial out. Our last assignment is going to be our lab. In our lab here, we are going to use our serial UART. And here we're going to have two assignments. Assignment 2 is optional as we are going to go through it, but I urge you, if you can do it, that would be great. This is how the communication is achieved. I have TX and RX. This is my processor with the USB interface. Those are my two communication lines. And the USB is taking my information to the computer or from my computer through the USB interface to my microcontroller. Normally, in old systems, we used to use TTL logic, transistor logic. That is 5 volt. It used to be slow. Now we have other alternatives, and we are going to see next a comparison of those alternatives. We have, for example, in addition to UART, we have, and we used already, the I2C. This synchronous multi-master slave, this is my master, and I have many slaves, and they are communicating over 2 lines. And there is another scheme that's called SPI, Serial Peripheral Interface. I have here again synchronous serial communication. This is good normally for short distances, and it is used for embedded systems. This is my master, and I have a group of slaves. Here you may see a comparison between UART that we are going to use in today's lab and I2C and serial peripheral interface. This table here, it gives a comparison between different versions of Arduino, Uno, Leonard, Mega, Do. Those are comparison. What are the capabilities of the serial port, the UART, and how many ports it might have? Currently, we are not using the TTL, we are using RS-232, and that is giving us faster response, and we can transmit data over longer distances with RS-232. As we have seen, we are setting at the very beginning the baud rate. Baud rate is how many bits that we can send per second, but not byte. I am sending baud rate, it is bits, but how can we convert it to bytes? First of all, my data is not all my 8 bits. I have extra. What are extra? I have a start bit, stop bit, parity check bit. When there is a communication, I start by sending a start bit. Then I am sending my data. When the data is sent, I am sending an end command. This is the end. Another bit that would say, yes, we have transmitted the full byte, and this is my stop bit. Now, after receiving the stop bit, what happens is we make a check through what is called parity check. In parity check, we need to make sure that the data received is correct. How we do that? The processor counts for each byte that was sent the number of ones. How many ones do we have? I am sending 0, 1, 0, 0, 1, 1, 0, 0. Those are 3 ones. I am setting my protocol with the sender. If I receive odd number of ones, I will be high. The parity bit will be high. If I don't receive an odd number, the parity bit will be 0. So I am receiving the parity bit and I'm counting the number of ones that I have and comparing it against the parity bit. If it matches, that's good. If it doesn't, I will send back a message to the sender, please send again. Here, we are setting the protocol. We can be counting parity bit, and if it is odd, I'll be high. Or if it is even, I'll be high. That is what's called parity odd or parity even. That is for communication. So I'm sending start bit, stop bit, and parity check bit. Those are added to my data. So if I get my baud rate and divide it by 10, I will get approximately how many bytes do I send. Here I have common baud rates that are available. Normally, the default we have, it is 9600. Then we are going to use a simple program to check that. We are reading bytes, and we can use parse int or parse int because it's going to be character and converted. And based on that, we can do many things. We can convert a number to a string, for example, or vice versa. So in this exercise, we are going to be reading pin A0. And if it is true, if we have something, we are reading a character, we are going to be depending on the character. If the character is good, that means true. I will do some action. If not, if character is S, that means false, I will do another action. This should be a very simple one. We are just communicating with the serial port and transferring characters. Then in the second one, we are going to have two Arduinos communicating, speaking to each other. If you have another Arduino, do it. If you don't, you may skip this one. As I said, it is optional. It gives you the instruction on how to do that. And step 3, it is for your innovation to come up with an application for this task. Here we have Jordan is saying 8-bit in the ASCII extended to 128 minus 255. Yes, that is true. There is ASCII and there is extended ASCII. Why do we need extended ASCII? Because we have not only English language, we have other languages. But for other languages in the old days when we started using the personal computer, the first personal computer I used, as it was still brand new, it was 1982. While I was doing my PhD, it was IBM, and it used to have this 128. But we needed more character. That's why we got the extended. After that extended character, we used to have the computer to be able to speak another language beside English. It can speak, for example, French. It has the French character. Or it can speak, for example, Arabic. Still, it can accommodate that. And when we used to download Windows, we used to say download and download which language that I'm going to use. So if I want to change language, I have to go to setting and change that language. And this is another setup. But afterwards, we got a universal setting, one universal setting, and we had a huge ASCII table. This ASCII table, not just 8, it was extended to 16. So you can imagine how many languages. And all what you need to do is just to go and select all the language that you want to speak with your computer. Thank you, Jordan, for this information. I believe we should be ready to go. Your breakout rooms are ready, but before you go to the breakout rooms, I want to tell you that next week, that will be our week 9. In addition to our task, I will be discussing with you your project 2. And in project 2, as we did with project 1, project 2 will be presented during our meeting, week 10. And if you don't present your work, no credit, no credit. Okay? So please start thinking about what you will be doing for project 2. Now you may join the breakout rooms and I'll be stopping by as usual. Are you available, Paul? Hello, Paul.
Hello.
You may share the screen.
Okay. I'm still commenting my code, but
I went to your room, breakout room, but I couldn't find you.
oh. Yeah, like I say, I'm still commenting my code, but it seems to be working here. I'm turning the potentiometer right now. It's at 13%, 9, and then I can go back up.
Okay. This is the first part, I believe.
Yes, the first part.
Okay.
Yep, so I'll keep going.
Please do. Thank you.
Okay, thank you.